Yeah.
She's not a wizard.
Thanks. Wizard. Name's correct.
What is
They have a wand.
There you go.
They tell the future.
Yes, they do. They have a little ball.
your grandpa the wizard? That's awesome.
That'd be really cool though. If you feel like my grandpa's a wizard, what's your grandpa do?
You're the plumber.
Alright, so number one starts off with a Pythagorean theorem question. So first thought is Pythagorean theorem's geometry. Why do we have that with this unit? Well, because it's squared and we're doing square roots, so it fits in pretty good. We're trying to find side B, so I just set this up as 7 squared plus B squared equals 14 squared, the hypotenuse. So that got me 49 plus B squared was 196. Then to solve for B, I subtracted my 49 from both sides. So that B squared, that got me 147. Now to undo your squared, you square roots. And at first thought, I thought maybe 147 wouldn't, I've written a lot that hadn't happened yet. Okay, I'll just do it up there so we don't have to wait on this all day today. Then, anyway, you get when you... Oh, well, we'll give it one more try then. When you look at square root of 147, I thought maybe it wouldn't break down, but there wasn't any choices that didn't break down. So I knew I had to figure something out. If you look at your old school, middle school divisibility rules in middle school, you were taught to add the digits. So if I'm looking at 147 and I do 1 plus 4 plus 7, add those digits, that's 12. 12 is divisible by 3, which means 147 has to be divisible by 3. If you check that out, that ends up being a nice perfect square. It's 49 times 3 that gets you to 147. And the square root of 49 is 7. So you end up with 7 square roots of 3. Now, whoa, the whole thing just went away. Okay, I talked to first period about this. One thing you could do when you got that square root of 47, if you were struggling on how to break it down, you could hit square root of 147 in your calculator, write down the decimal equivalent for it, then go through the choices and see which one has the same decimal equivalent. I'm saying. Alright, so that was D as in dynamite. Numero dos. Number 2. I got the cube root of 4x times the cube root of 25x. Now, in the bell ringer, I just told you, you can multiply if it's not the same underneath as long as the index is the same. And this one is. It's a 3 to 3, a cube root with cube root. So my answer is going to be a cube root 4 times 25, x times x. Can I break any of that down? Does 100 have a perfect cube that'll go evenly into it? Nope. X squared doesn't have a perfect cube in it, so Caleb's right. That's all C as in Caleb. Alright, number 3, it told you to use your calculator. So make sure you remember how to type a cube root in your calculator. Hit math, go down to number 4, find the cube root. Make sure you round correctly because C and D are pretty close. Which one was it? C is correct. Good job, zing. Alright, number 4. Got to do some foiling on number 4. I've got 9 square roots of x plus the square root of y. This is an easy FOIL because I'm multiplying that by what I call the difference of squares, buddy. The conjugate, everything's the same but the sign's different. 9 square roots of x minus the square root of y. We've talked a lot about when we do that, we know our middle terms, our outer and our inner, are going to cancel out. Let's go ahead and start on the first. So my coefficient's 9 times 9, there's 81. On those variables, square root of x times the square root of x is just x. Okay, now here's what I was talking about when you do difference of squares. On the outer, that gets me a negative 9 square root of xy. And on the inner, that gets me a positive 9 square root of xy. So they gone. On the last, I got a positive times a negative, so that's negative square root of y times square root of y is just y. So that'd be B, as in Bobby. tough one. Square root of 4 plus square root of 100. Everybody, I'm writing again and it's not up there. Square root of 4 was 2 is what I wrote. Square root of 100 was 10 was what I wrote. So for number 5, you were just looking at 2 plus 10. Did you get C?
Oh.
Yep.
Oh, dang, I thought it was 60.
I mean, that was a tough one. Alright, so we got 5, even though it didn't show up there. Everybody got it? Square root of 4 was 2. Square root of 100 was 10. Okay, going to 6. We good? Alright, 6. I immediately on 6 marked out choice B and C. Reason I marked out choice B and C is because they didn't have a fraction, and I look at the original problem and it has a negative exponent. You know, when you have a negative exponent, you put it on bottom and make it positive. So it had to have a fraction and it had to be A or D. So that's the first thing I'm going to do is I'm going to take that thing and put it on bottom. So I'm going to put 1 over 6m to the 4th, 8k squared, plus 8k squared, dummy, 8k squared, all to the positive 3/4 power now. You got it right.
I did?
Yeah, you're just ahead of me still. Now, power over root is what I'm going to use next. That's a 3rd power and a 4th root. So this is the same as 1 over the 4th root of 6m to the 4th plus 8k squared, all to the 3rd power.
Couldn't you not do any more?
Yeah, you could just look, yeah.
Just say, so you could have marked out E as well, right off the bat?
Because they got them in the wrong order, yeah. Yeah, you're good on that. Alright, so 6 we had A is in antelope. 7. You could type 7 in your calculator and it would get you the right answer as long as you typed it correctly. I did it using power over root again. I had 243 to the 4/5 power, which means 5th root, oops, 5th root of 243 to the 4th. Okay, I don't know what 243 times 243 times 243 times 243 is. I don't know what 243 to the 4th is. But 243, the 5th root of that, I can figure that out because I know it's not 2 because it's not an even number. So if I just start listing powers of 3, 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 3 to the 5th is 243. So I've got 5th root of 243 is 3, so then I just got to figure out 3 to the 4th, and I just did that, so you ought to get 81. And your calculator would have done that for you. Page 2. I don't know what choice A is. I have no idea where you get choice A from. That's just like the weirdest thing I've ever seen. A lot of people in first period chose B. Wrong. Okay, if you type 6 to the 1/2 power in your calculator, it will get something that rounds to what B says, but that's not what the directions say to do. Directions says to write with radicals. So you got to know that a 1/2 power, if you have something to the 1/2 power, and we've said this a lot of times, that's your power over your root. So you need the first power of the square root of 6. So you're just looking for the square root of 6, which would be C. All right, on 9, look at choice B. They didn't even change anything. B says exactly what the problem says, so I don't know why you picked that one. Did anybody pick it? Just wonder why you would, I don't know. Alright, it says to first simplify by converting to rational exponents. You could just type that in the calculator as it is, but if I did rational exponents, I would have 5 to the 16 over 4 using your power over root. 16 over 4 is the same as 4. So now I just got to figure out what 5 to the 4th is. 5 times 5 is 25, times 5 is 125, times 5 I think is 625. Is that right? Yeah. D, 625. Alright, number 10 is the one first period had the hardest time with, those powers of I. They didn't do as good when we made that chart. You remember we made a chart the other day? I need I to the 17th. I'm going to do this real fast because it's bugging me.
Can you do that?
Whoa, whoa, whoa. What? You confused me, Keston. Do what?
Wouldn't it always be off?
Maybe not.
Alright.
That
That was magic.
Is there one for all but one?
Don't confuse me again, Keston. No.
Is there an invisible?
Ah, you quit talking. You started this problem up here, I'm having.
No, it isn't.
Yeah.
Where is it picking it up at? Not there. It's my growl face at Keston.
I don't even know what I did.
I'm just thinking of it. You asked a question and you made me stop and it went crazy. No more asking questions at math. That's unheard of. Alright, let's give it a whirl again. Thank you. Alright, so I to the 17th. What we know to start with is that I squared is negative 1. We're given that when we started this. Now we made a chart. I'm not going to go through the whole chart again, but I am going to go through 4 of them because we discussed and talked about that that's when the pattern starts repeating on powers of 4. Because if I did I cubed, that's the same as I squared times I. Because 2 and 1 will make 3. Well, I squared is negative 1. So you're negative 1 times I, which would be negative I. Okay? I to the 4th, if I go to the power above that, is I cubed times I. But I cubed is negative I. So negative I times I. I times I is I squared. So we got a negative I squared. I squared is negative 1. So negative negative 1 is 1. Okay? About I to the 5th. The I to the 4th times I. I to the 4th is 1. So 1 times I is I. Now if you go one more, I to the 6th, it's going to go back to negative 1. So it goes negative 1, negative I, 1 I. Negative 1, negative I, 1 I. That's the pattern that keeps repeating. So I need to figure out this I to the 17th with something that has a factor of 4 in it. Yes, ma'am.
I don't know what was on my finger if it came up on the page.
What is your question?
The
No, I was
bugger.
trying to think.
Oh, yeah. Oh, thank you. I didn't know what you were doing.
Comment.
16. If I can make I to the 17th have a 16, that's Grace has that on her paper. That's 16 and 1 makes 17. And then the point of doing that is what she's showing me. I to the 16th is the same as I to the 4th to the 4th. Okay, because 4 times 4 makes 16. I to the 4th is 1. So you got 1 to the 4th times I. 1 to the 4th is 1. 1 times I is I.
That's way too much for my brain to comprehend.
Well, this wasn't the first time we've ever looked at it, Keston. That's one of your issues.
What did you say?
Woo! Alright. Number 11. Dilemma with number 11 is you can't have an I on bottom. 10 was C. Yeah, 10 was C. So on 11, to get rid of that I on bottom, we have to multiply like we did earlier by its difference of squares, buddy, by the conjugate. So it's 4 plus 3I over 5 plus 2i. To get rid of that I on bottom, we're going to multiply by 5 minus 2i. Everything stays the same, you just change the sign. It's difference of squares, buddies. So you got FOIL on top and bottom. So there's a 20. There's a negative 8i. There's a positive 15i. And there's a negative 6i squared. Remember, I squared is the same as negative 1. So this negative 6 times negative 1 is a positive 6. So you've got 20 plus 6. Then on your i's, negative 8 and 15. So there's your numerator. Now that can kind of tell some of y'all the answer. But I'm going to go ahead and finish anyway. FOIL the denominator now. I got 25. Here's where our middles are going to cancel out. Minus 10i and plus 10i. He gone. Minus 4i squared. I squared is negative 1, so negative 4 times negative 1 is a plus 4. 25 plus 4 is 29. Now, when we did those in class, I circled that and was done. But the choice didn't write it that way. That whole thing being over 29 means you can write each one of them over 29. So you've got 26 29ths plus 7i 29ths. Boogity, boogity, boogity. That was B as in boogity, boogity, boogity. That's a cool loaf of bread there, Grayson. You'll crack me up. Alright, a couple different ways you can do number 12. Easy thing to do when it is divisible, you just divide it. That's the short way on this. So 18 divided by 3 will get you next to the 6th. Okay, other way to do it, since it's cube root, you can break those powers of x down into cubes. 3, 6, 9, 12, 15, 18. What was your question, ma'am?
Like, you said you could just divide 18 divided by...
When it'll go into it evenly. If it doesn't, you got to do this way.
Okay.
Okay, so now since I wrote x cubed because it was cube root, and I wrote as many of them as it took to add to 18. 3, 6, 9, 12, 15, 18. So the cube root of x cubed, that cancels out, and that's x. I have to do that 1, 2, 3, 4, 5, 6 times. So you get the same answer.
Okay.
Okay. Thirteen, 13, 13. We had that square root of 147 on page 1 earlier. What was the one we just did? X to the 6th.
No, I said square root of 147 is 12 plus 12.
No, that's not going to help me any.
I thought that's what you were asking.
Oh, my bad. Alright, first off, addition and subtraction, we got to have a common denominator. Do we have a common denominator on those three? Yeah, the last one's written dumb, but we do, because we know the square root of 25 on that last one's 5, right? So just mark out square root of 25 and put a 5. I'll do that in a second. Now, but in order to be able to add and subtract these, stuff underneath the radicals all got to be the same. So we got square root of 3, square root of 3. That's good. I need to see if I can get a square root of 3 out of this. So we used that one earlier. I check again. I do 147 divided by 3, and I see it's 49. Square root of 49 is 7. So this is the same as 7 square roots of 3 over 5 minus 2 square roots of 3 over 5 plus 1 square root of 3 over 5. Ma'am, what would you be doing? 7 of them minus 2 of them is 5 of them. 5 of them plus 1 of them is 6 of them. So we have 6 square roots of 3 over 5, which is D, as in dandelion. 19. We ready? Got the square root of 19 over x to the 4th. We talked about when you got a whole fraction underneath the radical, that means you have to take the root of the numerator and the denominator. Dilemma then is you can't leave a radical on bottom, but in this case you don't even got to worry about it because on the bottom x to the 4th is a perfect square. What times itself equals x to the 4th? So what? X squared. Good, Aaron. 19, does that break down? Nope, but it's okay if it doesn't. That's your answer, which is B, as in Boomland. Fitting. Alright, looking at your choices, obviously you're not typing this in your calculator because your choices all have a fraction and a square root in it. So we just need to reduce and break down. You've got an option on how to start. You could look at your numbers outside the radical, the 54, the 60, and the 12. Those all have something in common. You could go ahead and reduce those. Or you could say, well, I want to break down the radical first, because square root of 200 will break down. So you could go ahead and do that. Either one will work. Anybody want to give me an idea on what you want to do first here? You want to reduce first or break down the 200 first?
Break down.
Okay.
Reduce.
Did you do it, though? You tried it, I tried it. Well, I reduced it first in first period. I think I kind of want to do the radical first this time, just so see what works easier. We know the square root of 200, perfect square-wise, is 100 times 2, right? Square root of 100 is 10. So I'm going to bring a 10 out, multiply it by that 60 that's already out there. So I got 54 minus 60 times 10 is 600. Square root of 2 still left in the radical. Now, here's what I should have reduced first, like Michael said, because now that's harder to divide in my head. Well, not really, because it's still 6 is the only thing they all got in common, but I know the answer is the reason I know that. 54, 612, I'll share a 6. 54 divided by 6, 600 divided by 6, 12 divided by 6. Why can you not say that this is 50? Why can't you go farther there? Because 100 over 2 is 50. Why can't I do that?
It's a square root.
No, because I reduced this and it has still the square root. Go ahead, Zane, you're about to say it.
9.
Good, it won't go to the 9 evenly. So once we used it, you can't like assign it to your favorite parts anymore. That was B, as in Boomland. Last page. Yeah, and in first period was asked about that. What Michael just said. This study guides only has 20 questions. Some of the previous ones we've been having 25. Every time when I make a test off this program, I click how many questions I want it to have. I'll always do 20 or 25. Those are easy to figure grades in your head. If it's got 20, it's worth 5 each. If it's got 25, it's worth 4 each. If you ever wonder why your teachers do that, that's why. So it'll always either have 20 or 25. And I really don't remember why I went back to 20 on this one, but I did, so it's got 20.
The test is too.
All right, 16. 7 plus the cube root of 3 times 7 minus the cube root of 3. So this is another difference of squares, another conjugate here. Our middles are going to cancel out. My first, I've got 7 times 7. My outer, I got minus 7 square roots of 3. And on my inner, I got plus 7 square roots of 3. They gone. On my last, these aren't going to cancel out because it's a cube root times a cube root. Positive times a negative is a negative. Cube root times cube root, 3 times 3 is 9. Before we've had that cancel out, but it was the square root when it did. Cube root and 9, 9's not a perfect cube. So that'll be your final on that one. Which was C. as in California. That's where I'm going after school. I'll be back in the morning. Somebody in first period tried to argue that was impossible, so I went on a whole tirade about how it was possible.
I mean, you can fly straight there and straight back.
I didn't say what time in the morning I'd be back. I mean, I could roll in at 11:59 and still be in the morning. He was mad at me because I kept on going. It was fun. There's a kid in there that always likes to argue. Well, it's not that. All right, 17. You can actually get the answer for 17 just by looking at the graph. Be careful with choice B, though. On 17, it's not B. And I understand if you pick that, how it might have tricked you. But the way they wrote B, you got to look close at it and see. It is not an ordered pair. Yeah, the ordered pair 2, 0 is the intersection, but these things don't mean ordered pair. It's got braces on that. That means the numbers 2 and 0. And that graph does not cross the x-axis both at 0 and 2. It only crosses it there at 2. Okay, which tells you the answer. It has to be 2. If you didn't know that, I mean, you still wanted some algebra proof, take the equation that it gave you, x plus 5 equals square root of 2x plus 3, get rid of the radicals by squaring everything, and you've got an easy junior high algebra equation to solve. I'm like writing hard. Did that sound louder? It sounded louder to me. Maybe because I wasn't talking for once. I don't know, Grace. I don't know, Grace. All right, on 18. We introduced, or no we didn't, we reintroduced and reviewed the imaginary number in here, this unit, but that's not choice on number 18. You ought to be able to look at that and say, well, there's a negative underneath the radical, my answer is going to have an I in it, it's imaginary, and that's correct. But they didn't give you an imaginary choice. So the best answer, they said, is it's not real, A. All right, let's look at 19. Negative cube root of 7x over y. All right, so we just talked a few problems ago about this means this is the same as the negative cube root of 7x over the cube root of y. And there's your dilemma. You can't have a radical on bottom. Now, if that were just a square root of y on bottom, you'd multiply it by the square root of y. But that won't cancel out a cube root. To cancel out a cube root, you need a third power. So y times what would be y cubed? Y squared. Very good, Caleb. So we're going to multiply by the cube root of y squared. So on the top, that gets me the cube root of 7xy squared. On the bottom, y times y squared is y cubed. So you've got the cube root of y cubed, and then the cube root and the cube cancel out. You just got y. Which was C. As in cuckoo. Last one, number 20. Gives you a little hint in the directions here. Simplify by first converting to rational exponents. That means fraction exponents, which means power over root. So on the top, this is power over root, so that is x to the 8/5. Power over root on the bottom, so that is x to the 8/7. Now you've got same base, x and x. It's division. What do you do with your exponents on division? Well, subtract them. Very good. So I got x to the whatever 8/5 minus 8/7 is. Okay, common denominator of 35, that would be 56 35 minus 40. 35ths, 16 35ths. So I got x to the 16 35ths, which is not a choice. So now I got to take that and do power over root with that. Power over root be the 35th root of x to the 16th. Shazam! What do you think? Easier than has been, maybe? I think so. Are you alright?
I think so.
Alrighty. Be able to use your study guide in your notes if you want to, so have those.